Good evening, everyone. It is 8:40 p.m. Monday, July 7th. Today we're going to continue on with two-dimensional dynamic programming. So let's give this a go. Given two strings, text1 and text2, return the length of their longest common subsequence. So you know what I was going to do? Let's add a clock on this too. Yeah, don't want to spend too much time. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with the same characters. Can be none. I guess it's similar to the common subsequence problem. Which, if I remember correctly, I started this because I was trapped on that one. That was on that video I was not having a good time on, which is why I implemented the timer. So I'm guessing this problem also not gonna have a good time on too. So I'll probably throw in the towel early on this one just so I don't waste too much time. Let's see. I do remember doing a problem similar to this in my algorithms class. It might have been the regular longest common subsequence, or it might have been this one. I remember this one was challenging though, because I think I do remember doing this one. I remember being a bit stuck on this one. Sorry, I was picking up my arm. Okay. The longest common subsequence is ace in this example here, which makes sense. So you get two choices. You could either keep it or you could discard it. So let's do we'll take the smaller one. So in this instance will be ace. So we have so if we can take it, we'll take it. If we can't, we can't. So in this instance, we'll take E, and then we'll have nothing. So the nothing one will go like C, D, C. So that's the nothing one. And then you can also do nothing from here. A, E, A, D, A, C, A, B, A, A. Right, so here's what the nothing ones. Right, okay, and so then continuing on with the C, then we go to the A, so then we can do AC. Then continuing from E, we can do ACE. If you see what we got going on here, the longest in here is A. Until we hit that C, then the longest is AC. here we establish the length of the words. Now I'm going to set up my 2D cache. I'm going to do this as a as an array because the dictionary, for some reason, in LeetCode will do memory limit exceeded. I guess it tells you that dictionaries they inherently store extra memory compared to arrays, which that makes sense. That's not really a big surprise to me. Okay, should establish my cache. Let's check that, make sure that it's established properly. That makes sense. Forgot to add the length in here. Let's try that again. Okay, looks fine. Perfect. And do def TP. I'm gonna say long word, short word. Just keep it simple. Do LL WSW. Okay. If LW is less than 0 or SW is less than 0, then we just return a blank empty string. Brother, leave it alone. Relax. Since we reach the end. So then what I'll say is if long word LW is equal to short word short word SW, then what I'll do is I can add a take. So I'm gonna say to include equals that. Whoops. Exclude equals that. I'm gonna say that include equals DP. If we're taking it, then I feel like this could have some issues, though. Like, we're gonna call this take. We're gonna call this move long, and we're gonna call this move. Oops. Move short. Okay. So that would be it. Okay. We're taking it. We're gonna use both. It's probably not really the best. Well, we'll see. Okay. I guess I don't really need the long and the short. I kind of did all this long short thing for that reason. If I'm gonna just move it here. Well, we're gonna do move long first because I feel like moving long first is just algorithmic speaking. I would assume based off like probability would be better on our time. We'll see. I guess I don't really need to do the number. Just because I'm not actually ever using it, so. That way I could just kind of move on without having to worry about, using it. Can I do Trimax? Okay. Let's see if that works. Did I click submit on accident? I did. I don't want to do submit, I just want to do regular standard run. Perfect. Cool. Alright, I mean, not perfect, because I didn't get what I wanted, but. I'm returning 0 no matter what, which is problematic. Because I'm using include, not take. Alright, that'll do it. Oh, okay, there you go. That accepted. Nice. Well, that wasn't as bad. I feel like that one is actually kind of easier than the other one, just oddly enough. But best time to buy and sell stock with cooldown. Okay, so I'm given an array called prices, where the price of our is the price of a given stock on the ith day. For maximum profit you can achieve, you may complete as many transactions as you like, and buy one, sell one share of the stock multiple times, with the following restrictions. After you sell stock, you cannot buy stock on the next day. You may not engage in multiple transactions simultaneously. You must sell the stock before you buy again.
Interesting.
These 2D ones are very interesting. I don't see how this is 2D. You know what was kind of weird is the yesterday, or when I was doing singular DP, was it yesterday or the day before? They were also 2D, which I'm like, why are these 2D in the 1D? But where's the 2D at? That's the question. Because the thing is, if I'm going in this with the mindset of 1 dimensions, I'm gonna be stuck here for 15 minutes because I'm gonna be misunderstanding the problem. So this one we're not going to start looking at. I mean, I guess it could, but it's like, I don't think it's very viable. So you have 3 options here. 2 options. You have buy, which means you'll take current. Okay, current minus the ith. Right? So that's going to be your value. And then you're gonna do like dp I like +2, and then sell will be current plus ith dp I +1. And then you could, I guess, skip. Can you skip? Is that a possibility? I think this question is actually not really descriptive enough. I'm confused, like, what exactly they are asking for. Oh, this is the same stock, I see. Is there a skip button? Can I skip? Because, like, you know, I'm gonna assume there's a skip button. So I'm gonna assume there's skip as well, which is just gonna be nothing, and then dp I +1. Yeah, I'm gonna mess this up because I don't know what the 2D is. We'll see. I'm trying to think. Let me get number of prices. Well, I guess one thing I can use is the time. The process I'm thinking about doing would be, I mean, in theory, it would be linear time. So if this isn't all in, then okay. Well, maybe I don't need a 2D, man. Then, I'm curious as to why this is qualified as a 2D then. We'll see. Maybe this is more like granular. However, maybe the first DP, because I was like tweaking my ass off on the first DP. Because I was like, oh my goodness, this doesn't feel like DP on some of the problems. Maybe that is just DP. Maybe my thought process of what DP was 2D DP. Maybe. We'll see. So cache, it's going to equal an array of none times the length of prices. And we'll make a def DP. We'll call this day. Oh, wait, I do see the 2D. Oh, yeah, I think I do. Hold up. Let me draw this out real quick. This is the same thing as the 2D that was from the other day, where it was like, it does not seem like 2D whatsoever, then it becomes 2D. This was supposed to be on the 1D last, was it yesterday? No, I think it was the day before. Maybe it was yesterday. So my options here at 1. So I can be at 1, 0. And from 1, I can be at I'll be at 1, or I can be at -1. And so if I write what I did, this is at the ith index. You know, maybe I'll just put this is at the 0th index. 1 index. Genuinely, I think I might have to do that because I'm trying to think about how else I would do that, but I don't know. I'll flip profit here, I guess. If day is greater than or equal to the length of prices, then we're out of bounds. What? What? Something wrong here? Did I do something wrong? That seems interesting. Turn 0, I guess. If day profit not in cash, then we're going to basically say that cash of day profit is equal to whatever solution we find, and then we're going to return cash of day profit. Okay, so my option is to buy, it is to sell, or it is to skip. So I can only I'm wondering if the 2D is the hold or the profit. I guess we'll find out when we run this. The hold's gonna be like whatever I'm holding at the time. Okay. So I'm going to say buy equals buy, sell, skip. They all equal 0, 0, 0. I could do buy anytime I want, so no. Actually, I can't. So I'll say if hold equals 0, then I can buy. Then I could say buy equals dp of day plus 1, just going to go in the future, profit profit and prices of the day. We're going to do prices of the day. Else, we can say sell profit plus plus prices of the day minus hold, and then hold will now be 0. And then if we skip is just going to be dp of day plus 1. Oh, I should put day plus 2 here. Day plus 1. Profit and whatever hold was. And then solution will simply just be the max of buy, sell, skip. Okay, return dp of 0, 0, and 0. Will this work? Probably not. Huh. Ah. Right. Slip. Infinite time loop. Nope. Oh, okay. Stuck at a 0. Oh, here you go. I don't need profit. Ha. Stuck at 0 because. Okay, we don't. How about this? How about I switch this to hold? And I put this to a guilt, something like that. Will it work? Probably not. I don't want to delete profit just yet. Huh. What problem is this? What is this? Huh? Ah, they hold. Yeah. Okay. Better. Not great. Better. They at least got something on the board. Oh, well, that's gonna print nothing. So put it out of bounds. Silly, silly, silly. Well, you know what, Sterling? Why not? Don't even know how to code, bro. It's my first day out here. Type shit. Hmm. intriguing. I'm gonna use him. Oh, I guess I don't need to track the hole, do I? Because... yeah, I don't need to check the hold. Well, I mean, we'll see. I don't know if this is going to change much, but... and runtime error. Yeah, sure. Runtime error. Oh! That's why. Exactly what I was checking to see if I was holding a coin or not. Forgot about that. That's exactly why I was holding it. I'm gonna put hold as a boolean. Hey, worked out, actually. Will it work out on big things? Probably not. We don't really find out. Damn, got pretty far before it crashed. The issue here is I'm buying. Almost done with this one. Buying here, then I'm selling here. I need to be buying here and selling here. Honestly, what's stopping me from doing a greedy approach and just buying the first one and selling the last one? I mean, I guess I could buy multiple, but it's like... I guess, actually, never mind. That wouldn't make any sense. My cache is messed up. How do I cache this properly? It's skipping this one step. Curious. I am curious if this actually changes anything. It worked. Let's see how far this goes. Okay. It did not work. It's very swift on that judgment of how fast things are working. It's always buying the first one and then just ignoring the rest. So hold on, this is a small one, so I can easily dissect this one. Versus like the big ones, like it's gonna take me a minutes just to get to the actual problem part. Okay. Oh shit. So my order of operations is buy, sell, skip. No matter the order of operations, it should work, but it's not working. So that means I'm doing something wrong with my cache. So here I'm storing that 1 -1 equals -1. Ooh. No, oh shit. Well, okay. Same problem. It's my cache just fucked up. Does this work? Actually, what am I doing? I can just indent. Damn it. Fuck. Crap, man. Anyways. Okay, so put that there. Then I say, 2 equals 2. No, I guess my profit system makes sense. Because it's like, if you're at this day and you have this much profit, no matter what you do, like, the maximum is going to be the maximum. Like, I feel like the cash does make sense. I think maybe it's something else that's a problem. Sure. So tricky. So tricky. So tricky. These didn't make it past like 70s, you know. I'll watch the videos though. I truly understand it, not just copy and paste.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve best time to buy and sell a stock with a cooldown. And this is actually a very interesting problem and a very challenging problem, but honestly, I'm going to make this problem look like a joke today, and that's not because I'm really smart. It's honestly only because I know how to draw a picture. I'm sure you guys know how much I like drawing pictures for LeetCode problems and how helpful. The main thing here is we can either buy or we can sell, and we can only sell if we have already bought the stock before. So when we start out at this array, right, we start at day 0. At this point, at the beginning of the array, are we buying or are we selling? Of course we're buying because we don't own the stock yet, so we can't sell it. So that's one part of the state that we have to kind of keep track of. Are we buying or are we selling? And it's not too hard because it's just a Boolean, right? It's true.
Oh, so you can't skip. Well, good to know, I guess. What? Well, then how the hell did I... okay. I don't know. Okay, we're just gonna continue with watching the video.
True or false. And initially we're buying, so we have a choice at index 1, right? We can buy. So of course, one decision is buy. If we buy the stock on day 0, it costs 1. So if we do buy, what's our total profit so far? Well, buying costs money, so our total profit so far if we buy is going to be -1. Now, are there any other decisions we can make other than buying? Well, we definitely can't sell yet. We don't own anything. But we can definitely do a cooldown. Now, if we do a cooldown, then our profit is going to be 0 so far. And by the way, let me just draw a little 0.
Okay, so we can skip. All right.
Up here because when we initially started, our profit was also 0. Okay, now on the left path of the decision tree, what choices can we make now? Can we also buy and do a cooldown? Well, we already bought. We can't buy again. We have to sell now. Technically, we don't have to sell, but that definitely is one of our choices. The other choice, of course, is cooldown. So as you can kind of tell now, we always have a choice of cooling down, right? The main choice that we're going to be determining is are we buying or are we selling? The other choice can always be cooldown. We don't have to do anything. But if we do sell on the second day, you can see on the second day the price is 2. So by selling, we're basically doing a +2 operation, right? Initially, we had -1. We're doing a +2. So that means our total profit, if we sell so far, is going to be +1. So that's pretty good. Now, of course, if we cool down, the profit is going to stay the same, meaning -1. Now, let's quickly draw the decisions on the right side of the tree. If we cool down, then we can't sell because we haven't bought anything yet. So the same decisions will be present as the original decisions, basically buying cooldown over here, and the other decision is going to be buying. So here, if we buy, we saw that initially we had 0 as the total profit, but if we buy on the second day, that'll be a -2 operation. So our total profit so far will be -2. If we cool down, of course, it'll just stay 0. So now we get to a kind of interesting case. After we have already sold, then what are our decisions? Can we buy and then also have a cooldown? Well, the answer is no, and the reason is because remember, after selling, we are forced to have at least one cooldown day right after selling. So basically, just pretend like we skipped a day, right? We had a forced cooldown day, right? That's our one decision, and we can't make any other decisions here, right? This is our decision. We're forced to do a cooldown after selling, but after doing that, we know our profit is going to stay the exact same +1. After doing that, though, then we do have a choice of buying or having another cooldown day. So we can time complexity. You can see that the height of the tree that we're making is going to be n, where n is the size of the prices array, and the number of decisions at every point we can make is up to 2 decisions. So the overall time complexity is going to be 2 to the power of n. But we can actually use a very simple dynamic programming technique called caching in this case, and by doing that, we can reduce the time complexity to big O of n. The reason why is because the key for the caching that I'm going to be doing is one going to be the index, right? The index of what position we're at in the prices array. The second key I'm going to be using is a boolean for buy or sell. I want to know if we're buying or are we selling. It's a binary decision, so we can just use a boolean for that, right? If we take this key value, how many possible possible values could it be? Well, the index I, there's n different possible values for it. This buy or sell state is going to be 2 different states for it because it's just a Boolean, right? So if we take n times 2, we basically get 2 times n, right? Which we know is just can reduce to big O of n. So in this case, if we use caching, the time complexity will be big O of n. The memory complexity will also be big O of n because we are caching. If you're not familiar with caching, I'll be explaining it right now as I go into the coding solution. Okay, so now let's write out the code. You can see I already wrote out a few things. One is just a comment kind of explaining what we're going to be doing. We're going to keep tracking of the state, whether we're buying or we're selling. If we buy, we're just going to increment the index by 1. If we sell, we're going to increment the index by 2. Reason is because we remember we have to take a cooldown day after we sell. And remember, we are going to be using caching value. So now let's get into it. I'm going to be writing out a recursive function, DFS, of the prices array. I didn't really cover this base case in the drawing explanation, but I think it's pretty self-explanatory. If we go out of bounds, basically, if we have an empty array of prices, what are we going to return? Well, we can't make any profit off of that, so we're going to return 0. Okay, so that's great. And the other base case I just want to quickly mention is the case that if this pair of values, this I and buying pair, has already been computed before. So basically, if this is in our DP hash map, initially our DP hash map is empty. But if this is in our DP hash map, then we assume that the max profit associated with this key has already been stored, so then we can return that, right? So in DP, we can just use this key value and then return whatever that max profit we stored was. Okay, so now for the actual decision that we can make. And remember, that decision that we make is going to depend on only one thing. What state are we in? Are we buying or are we selling? So it's a binary state, right? So if else. So let's start with the buying. So we know in the buying state, we can do two things. We can buy or we can have a cooldown day, right? What's going to be the profit, the max profit associated with each of these? Well, if we buy, we're going to recursively call DFS at index I plus 1. And what's the state going to be? Are we going to leave buying as the same? Of course not, because if we just bought, then we're in the opposite state. We're in the not buying state. So in Python, this will literally just take that Boolean value and negate it, or in other languages, you could just do like the exclamation mark, but I'll leave this as is. So that's how the recursive call is going to work. Pretty straightforward, but the only thing is, if we bought, doesn't that affect our profit so far? Remember that.
All right, hold on. At this point, I should be able to get the rest of my own. That's gonna break it right here. Alright, let's see if this even does anything for me. Probably not. Probably be like, wrong. Okay, that's correct. I don't know realistically what was much of the difference between what I was doing and what he was doing. That's not the beauty of coding. Be so close, but nope. Alright, that's it for today. I went about 20 minutes over. Thank you for watching. I'll see you tomorrow.